This will be a quick video on the new Qwen Edit 2511 model, and the workflow here is simple. This is the model and the 4-step Lightning LoRa. This is the unit loader for the smaller GGUF model, and the same can be downloaded from here. I will be using the FP8 model. The file size is around 20 GB. You can get it from any of these two links. Above is the full-size BF16 model, which should work on a 32 GB or larger graphic card. For systems with low memory like 8 GB and 16 GB of RAM, you can use the GGUF model instead of the FP8 model. And this Q5 model should work for a 12 GB VRAM system. Next is the text encoder, LoRa and the VE. This is the Lightning LoRa, which makes the image generation possible in 4 steps instead of 20 steps. These red color nodes are the one where you need to select the files you download. The prompt goes here. This LoRa flow affects the sampling logic I've not tried with Qwen model. CFG norm is to control the CFG in case your prompt goes wild. Below are the 2 beta nodes, and this is the first time I am looking at them. The note here says if using Lightning LoRa, which I am, I can generate an image in 4 steps, or else in comfyUI, it takes 20 steps. The workflow had a default prompt about a leather couch and a furry texture, so I tried the same. In this part, both the sides and the center does not look real. The fur is way larger than it is supposed to be. I will try a few prompts with the FP8 model now. The prompt used will be shared with the workflow. My prompt was, the girl is wearing a sweater, her face remains consistent, and a golden star on top of her head with green lights, golden bells, butterflies. She is holding a Christmas toy, and her head is slightly tilted with playful expressions winking and smiling. I also said about blue jeans, and she is surrounded by green blurred bokeh lights, dreamy background. The character's face is acceptable, not too different from the real image. The image size is being controlled above. This is the node used to keep the size in check. But now I am using this resize image V2 from KJ nodes. This crop and resize option handles images easily. Same image, but this time the image size is different, and to do so I am using this empty latent image. Before, I was using the image given by the resized image node. The image size I wanted was longer than the image I have uploaded. And the prompt used is on the right. Here I asked for a grid of anime-style girls, which is divided into 4 sections. I asked for a consistent face, hairstyle, clothing of character in all the sections. Top left, the girl stands with hands crossed in front of her chest, head slightly tilted, large bright eyes smiling sweetly. Top right, both hands raised, eyes wide open, cheeks slightly blushed, surprised and adorable expression. Bottom left, head tilted, one eye winking, tongue slightly sticking out, playful expression. I think the image generated is fine, but the consistency was a challenge. I asked for 2 characters in the same image, a real person and the second to be the chibi version in the first person. Real person on the left and the chibi character on the right. The chibi character should be similar to the real person precisely, with large eyes, anime-inspired style. I asked for graffiti elements in the background, and if I exclude the plastic skin, then the image generated looks good. A hand holding a flat image element, similar to a photo print on a tabletop surface. The image should be the chibi-style version of the subject in the reference image. The new model has Relight LoRa baked in the model, so I tried testing it by relighting the image on the left. It works with a subtle change in light, but then I thought, was the previous model not capable of this? I am sure Flux Context was able to do this. So this is the Qwen Edit 2509 FP8 model. And it failed. So it worked in the new model. The relight works, but the difference is subtle. The model is also capable of looking at the object from different angles, if described properly about what you see in the background while looking from a different angle. I will use the table image and we'll try to change its surface. Something similar to this wooden texture. My prompt was replace the tabletop surface in image 1 with a wood material from image 2. One step takes around 10 seconds. Previously, when working with a single image, it took around 6 seconds. It takes around 50 to 70 seconds on my 4060 Ti 16 GB card. And the table surface did not change as per the reference image given. I tried a couple of times, but it did not work. Later, it worked. I added a resize node. The image given was around 4,000 pixels, and using a resize node made reading fewer pixels possible. After showcasing the model's multiple image editing capabilities, such as changing objects, combining two characters into a single image, and generating grid images from one reference image, it's clear how powerful these image edit models are. The only limitation at the moment is the overall image quality. Even so, these releases have already made a strong impact and earned recognition within the generative AI community. The real game changer will be the release of the closed source models API. Once that happens, I think the realistic image generation by those models will be on a different level. And it failed to generate goldfish twice. The fish on the right is basically a crossbreed of a goldfish and a clownfish. I have made a few changes in the workflow. And this link, it is the GGUF text encoder for systems with low memory. You can get a smaller text encoder from here, so overall everything fits in your VRAM plus system's memory. This text encoder will need a GGUF node, which I forgot to add. The node is added. The Q3KS GGUF encoder you see selected worked when I tried editing an image. You will need to replace this and this node with the above nodes to use the GGUF unit and the text encoder. Getting back to the workflow, these are the connections for the 3 image options we have in this workflow. This is the preview of the first image we upload for edit. And this is where I will upload that first image, which then goes to the image resize node. Let's look at a method for InPaint an image. I will create a mask for the woman's hair, and then click the Save button. The mask from the Load Image node is connected to this group of nodes. I will run the workflow now, and the mask is visible here. Right now, the image I uploaded goes to the K-sampler through the VAE encode node. And below is the option for an empty latent image. Now there is a third option as a latent noise mask. This should make the K-sampler work on the masked area only. The prompt for this is red hair. I will activate these nodes and run the workflow. The girl's image you see here is because I tried on a few images before recording this. The InPaint took 49 seconds and it worked. The woman's hair is red in color. Now instead of giving the mask, I will give the image for edit as it was before. As this is an image edit model, so it should work. And I got the result. The color was changed without any issues. The image on the right is the image from InPaint, and on the left is the edit done by text prompt. These images are identical, but what if I want to point to a specific object to edit? I will try putting a coffee cup here. My prompt is simple, a coffee cup on the table. The result is generated, and the cup is on the book. I changed the prompt and tried again, and the book was removed. So it works as mentioned in the prompt about removing the book and the pen from the table and placing a coffee cup at the same place. Now instead of a mask, I will give the image for editing. I got the result. The edit done based on the text prompt removed all the books and placed a coffee mug. So the InPaint function is useful in certain cases. Now let's look at OutPaint. I have to change the image resize node to keep it simple. This connection will be removed, and I will be using the other node for OutPaint. I will bypass these nodes for now and clear the masked area. The resize node will change the image width to 1624 from 1024 pixels. I ran the workflow, and in the preview, I can see the image with gray areas, which are the extra pixels added. But this gray color might be a challenge, so I will change the color to black, which can easily be detected on this image. My prompt is simple: remove the black area from the left and right side. And I ran the workflow. So it works, but there is a problem with the lamp. I will run the workflow again. And now it looks perfect. I tried again with a different image, and the result looks good to me. So that was the resize node with padding. I will keep it on the side, and now I will try the OpenPose workflow. This AUX preprocessor needs to be connected in place of the third image, like this. In my case, I am working with only one image, so I should be making this connection on the second image. I will make it as it was before and upload an image for a test. My prompt will be the same I was using when I made the video on the older version of Qwen Edit Model. It was working if you had seen the previous video. Let's see if it works now. I will let the size be at 1248 pixels and run the workflow. I got the result, and I really got the pixel perfect result. The model responds differently compared with the older version of Qwen model. I changed the prompt and queued the workflow again. The character got a gun in her hand. So there was some object in her hand which seems to be fixed now. I tried using the Canny Edge preprocessor, and I really like the image generated in reference to the police girl. The character's foot is out of the frame again. Instead of giving the uploaded image in the K-sampler, try giving the empty latent image, and the resolution can be taken from the OpenPose node group, like this. The resolution for the resize image node or the empty latent image should be referred from here. The result now may not be in reference to the police girl. In such a case, we can use prompt to get reference from the image one. There are many options to try with, like this depth map. My prompt will be police running in the fields. The example I took to show the depth map was not good. The dressing got changed due to the character's dress. This can be a better example of using depth maps and giving different effects. The prompt used is given on the left, and the image will be in the Discord group. You have to check how well this GGUF performs. I tried only once with a Q3 model, and it worked for me. I hope the video was informative. As we wrap up 2025 and step closer to 2026, I wish you a joyful year-end and a wonderful start to what's coming next.